NAS protocol advancements in Data ONTAP 7.3.
By the end of this module, you will be able to state that Data ONTAP 7.3 is compatible with Microsoft Vista clients and new features of Windows Server 2008. You will also be able to describe new Data ONTAP tools for testing access permissions. You will be able to define an NTFS sparse file and explain how Data ONTAP calculates disk usage and reports quotas for sparse files. You will also be able to describe the minimum level of security for CIFS and the new transparent redirect feature of fpolicy. Data ONTAP 7.3 is compatible with Microsoft Vista clients and the new Windows Server 2008. Among the Microsoft features that are compatible with 7.3, we support SMB 2.0, NTLM version 2, and we match all performance gains from using folder synchronization. The new Server Message Block 2.0 protocol provides a number of communication enhancements, including greater performance when connecting to file shares over high latency links and better security through the use of mutual authentication and message signing. Data ONTAP 7.3 is fully compatible with SMB 2.0. The following are some of the advantages that SMB 2.0 provides. SMB 2.0 supports a way of compounding operations to reduce round trips, making it less chatty than version 1.0. This reduces network traffic and increases performance over slow WAN links. It's also more resilient to small network outages, making it more reliable. SMB 2.0 is more scalable because it supports much larger buffer sizes and an increase in the number of concurrent open file handles. Another feature of SMB 2.0 is Microsoft's new transactional NTFS, or TXF, capabilities in Windows Vista and Windows Server 2008. Transactional NTFS allows file operations on an NTFS file system volume to be performed in a transaction. Transactions can also be used to both preserve data integrity and handle error conditions reliably. Data ONTAP 7.3 supports SMB 2.001. When a client request to map a drive occurs, the storage system and the client negotiate the version of SMB. If the client cannot use SMB 2.001, then it falls back to SMB 1.0, preserving Vista or Windows Server 2008's connectivity. When a client tries to discover whether a server supports SMB 2.001, it initiates a TCP session to port 445 on the server and issues a normal SMB negotiate protocol request to the storage system specifying the new dialect. Vista clients remember which servers support SMB 2.001, so later new sessions attempt SMB 2.001 immediately. As customers would expect, existing NetApp storage systems upgraded to Data ONTAP 7.3 support Vista and Windows Server 2008 from an interoperability standpoint and from a functionality standpoint. Data ONTAP 7.3 also supports SMB 1.0 for legacy servers and other desktop clients. According to Microsoft, redirected folder synchronization will be 50% faster with Vista clients accessing a Windows Server 2008. Data ONTAP matches any performance gains introduced by Microsoft for the Windows 2008 server. In the past, when administrators suspected permission problems, they relied solely on NetApp support to help them trace the source of the problem. The new Data ONTAP sectrace command allows administrators to quickly find the source of access problems. Administrators use the sectrace command with a filter to trace access and incoming requests. The filter is based on a path and IP address of the client, or the Unix or Windows username. The access decisions to grant or deny the request are recorded in an EMS message. To use the Secure Traceroute command, or sectrace, the administrator will issue the command followed by one of the following actions: add, delete, show, or print status. The action is then followed by a filter. When adding a filter, use the -A at the end of the command line to indicate that you want to trace both allow and deny requests. We have on the screen an example of the command syntax, and the command just happened to be a little bit longer than the width of the screen, so it's wrapped one time there. So it starts with the sectrace add, -path, full path, and then the -NT user, and then the actual user, and then the -A at the end. Here's a tool provided by Microsoft for analyzing access control list information. And the command is simply cackles, or cacls.exe. And here's an example of that command. In the Windows environment, a sparse file is a file in which many of the data blocks contain zeros. The blocks in the sparse files that contain zeros are known as sparse data sets. Files like these are typically very large. Some examples of sparse files are files containing image data or a matrix within a high-speed database. The problem with files containing sparse data sets is that they use disk space inefficiently. Support for sparse files was introduced in the NTFS file system as another way to make the disk-based usage more efficient. The NTFS file system used compression as a partial solution to the problem. When the sparse file functionality is enabled, Data ONTAP only allocates hard disk drive space to a file for regions that contain non-zero data. When a write operation is attempted where a large amount of data in the buffer is zeros, the zeros are not written to the file. Instead, the file system creates an internal list containing the locations of the zeros in the file. This list is consulted during all read operations. In this way, maintenance of the sparse file is transparent to all processes that access it. The default data value of a sparse file is 0. However, it can be set to other values. Swift clients can set the sparse attribute on a file which indicates that no space reservations are required for the file. Waffle returns all space reservation for the file when this attribute is set. To set the sparse attribute, the client administrator uses the fsutil tool from Microsoft. When Windows Client administrators set the sparse attribute on a file, then the space reservations for that file are deleted. Any reserved space is returned to the available space. Any attempts to set space reservations on a sparse file will fail. When administrators turn the sparse attribute off, space reservations will remain off as well until intentionally set by the administrator. I also want to point out that the sparse bit is preserved during the processing of Q3 snap mirror.